ever hear earthquake call and say, "Hello, Miss Lee, yes, it's me, earthquake, I come in Tuesday around 10? No, sir. Earthquake does arrive unannounced, and when it come, it shake all sense and sensibility out of we. Remain calm, stay inside, and do the DCH. Drop, hover, hold on. Once the shaking starts, you know it's earthquake. Make a quick move to a safe place. Don't run to the door, we are in the exit. Stairs might broke up or full of people. Take cover under a strong table or a bed, or crouch against an inside wall or in a corner, and cover your face and your head with your arms. Remember, DCH, drop, cover, hold on. Glass windows and doors, outside walls and doors in an earthquake, bad news. Take care yourself. Most injuries during earthquakes happen when something drop and hit people entering or exiting a building. Last thing, nobody run outside and ask, you feel it, you feel it? Remain calm, stay indoors until all the shaking stop, and do the DCH, drop, cover, hold on.
Yes, folks, drop, cover, hold on. My name is Winston Kafu Cabey, and today I'm speaking to our resident seismologist at the Montserrat Volcano Observatory, Rod Stewart, and of course we'll be talking about earthquakes and all the earthquakes that we are getting in the Caribbean, especially at this time. And I want you all to listen very, very carefully, because earthquakes and tsunamis are very, very dangerous things. And that is why we have brought our resident seismologist at the Montserrat Volcano Observatory in here with us today. So, Rod, no introduction. Everybody knows you. Former director at the MVO, now seismologist. How are things?
Things are good.
Good?
Yes. Things in terms of Christmas, New Year, life is good.
Okay, today we are going to be talking about earthquakes.
Yeah.
And this is a big topic. And folks all around Montserrat and around the region, they're talking about earthquakes and the number of earthquakes we are having and have had over the past year or so. First of all, what is an earthquake?
An earthquake is when the rocks in the earth have been stressed, pressures built up over a period of time, and they eventually either crack or slide against each other, and they do it very suddenly. And the bigger that crack is, which is what we call a fault, the bigger the fault is, the bigger the earthquake is. And some of the largest earthquakes in the world, those faults can be 1,000 kilometers long. And you can see the movement, you get maybe a meter of slip over the fault sort of thing. There's an awful lot of energy involved being released very quickly, and therefore we get shaking all around it.
Okay, we're living in the Caribbean.
Yeah.
So we'll be talking about earthquakes in the Caribbean. The first question is, are earthquakes common in the Caribbean?
Yes, they are common. The Caribbean, the Eastern Caribbean, is a place where two tectonic plates meet. So there are two thin plates of crust on the earth that are basically bumping into each other, and one slides underneath the other in what is called a subduction zone. And as that crust goes down, it generates earthquakes because of the friction between it and the bit of crust that is going underneath. So subduction zones all around the world generate earthquakes. They generate them at depths from near the surface down to, I think in the Caribbean, it's about 300 kilometers depth. And it's a continuous process. So it's normal to get earthquakes in a subduction zone.
Okay, the two plates that we're dealing with.
Yeah.
What are their names?
So it's the Caribbean plate, which is basically we're on the eastern side of, and the western side of it is Central America. The southern side is the north coast of Venezuela. And the north side of the plate is basically Cuba, Haiti, Dominican Republic. And that's bumping into what we will just call the North Atlantic plate. So those two plates are pushing into each other.
Now, as a seismologist at the Montserrat Volcano Observatory, we always talk about VT, or volcano tectonic earthquakes.
Yeah.
What's the difference here with the earthquakes we're getting?
In the sort of the theory and the physics, there's no difference. These are what we call tectonic earthquakes, where two rocks slide against each other. The only difference with VT earthquakes, volcano tectonic earthquakes, is the cause of the sliding is the volcano, not the subduction. Okay, so it's a different cause of the pressure, And because of that, we don't get the very large ones. So the tectonic earthquakes you get through the region, you will at some stage get a magnitude 7, maybe even a magnitude 8. From a volcano, you're not going to get those big ones. The biggest is probably magnitude 5. But the physics is identical. It's just the source of the pressure of the stress is different for VTs and tectonic earthquakes.
Okay, you said 5. But I did some research. As you know, I would do some research before I do this interview. And I had to, because the question that I was getting from folks who listen to ZJB, and especially to Volcano Vibes, was what was the largest earthquake in the Caribbean?
Okay, but I said 5 for VT earthquakes.
That's for VT?
Yes.
Yes. In terms of these regional earthquakes, do you know off the top of your head what has been the largest earthquake in the Caribbean?
I'd like to know what your answer is.
Well, my answer is that it was a tremor, and it says one of the largest hit in the Caribbean in recorded history, struck on Tuesday night at about 9:51 p.m., just over 25 miles off the coast of Great Swan Island, that's belonging to Honduras. And it was a massive 7.6 magnitude. That's a big one.
That's a big earthquake. The problem is, going back in history, it's very difficult to estimate the magnitudes. You know, they're a lot more hazy. So there was also a really big earthquake in, it was either 1830 or 1840, I keep forgetting which it is, one of the two, which happened between Montserrat and Guadeloupe. And it had a magnitude in the 7 to 8 range. It was as big as that. And the annals at the time say that every single stone structure on Montserrat was damaged. So we can get earthquakes up to magnitude 8 here. There was a time maybe 10 years ago when people thought because of the nature of the plate, magnitude 8 wasn't possible. But that's been revised because we've seen big earthquakes in similar locations around the world. So we could get up to a magnitude 8 here. And a magnitude 8 is going to cause an incredible amount of damage.
I understand that one of the biggest was 9 point something.
Again, it's getting very difficult to make measurements because they're very old. I don't think there's any magnitude 9s. I think the biggest is 8.5 or 8.7. But the thing is, it's what you call a logarithmic scale. I'm sorry to go into mathematics.
No, but you have to.
Yes.
What is a log?
A logarithmic scale basically means that an 8 is 10 times bigger than a 7 is 10 times bigger than a 6 is 10 times bigger than a 5. So a 9 would be 10 times bigger than an 8, which would be a huge earthquake. A magnitude 8 would have a fault, maybe 1,000 kilometers long. So a magnitude 9's fault would be 10,000 kilometers long. You're getting to the size of the Earth there. So it seems to be limiting around magnitude, the upper 8s, okay? But those are incredibly strong things to happen.
Not something that one would like to experience.
No, only from a distance.
Only from a distance.
Only from a distance.
Okay, let's come closer. Those earthquakes we are now having in the region, and I have to take a deep breath here because I'm almost certain you're going to tell me it's normal. But Rod, it cannot be normal.
It is normal. It is normal.
I mean, you say it with a smile, but in Puerto Rico, they've had over 1,000 earthquakes just in the past few weeks or days?
Yes. No, in the past couple of months. Since December. Yeah.
But that's not normal.
It is normal. The earthquakes do not occur at a steady rate, okay? We can do averages. We can say on average you'll have 1 magnitude 5 every year sort of thing. But over a long period of time, it's not a steady state of earthquake. So you'll have times when there's very few, and then you'll have times when there's a lot. And it's only when you average you can say, right, that's our sort of steady state. So it just happens in Puerto Rico, they're having a lot of earthquakes at the moment. But it's within the parameters of what we expect for that part of the Caribbean plate. So yes, it's normal. It's on the edge of normal. It is quite an unusual earthquake sequence. And I know a lot of people are studying it very closely. But it's not abnormal. That's what I'll say. It's not abnormal. So it's nothing changed. It's the sort of thing that we might get anywhere in the Caribbean.
I think that we don't live long enough.
That's the problem. The human perception, our lifespan is only, depends how
70,
how well you
years.
live. But it's the high tens. The earthquake sequence, the sort of averaging, we're talking thousands of years, even millions of years that these things are changing over. So we have this perception that things change when they're not really. They're just natural fluctuations in the earthquake activity.
I'm here on my computer, and I'm reading from a document here, more than 1,280 earthquakes have hit Puerto Rico since December 28th.
Yes. But again,
That's crazy.
It's this logarithmic thing. So I think, say, 2 of them were magnitude 6. I think that's right.
Some were 4.5,
Yeah, but I think 2 were magnitude 6.
6.4,
Yeah. Can I make my list?
5.9.
Yeah. So if 2 were magnitude 6, then you'd get 20 magnitude 5, 200 magnitude 4, 2,000 magnitude 3. And we can measure down to magnitude 2 sort of thing. So if you're counting all the magnitude 2s and 3s, yeah, you can have thousands of earthquakes. But people will only be feeling the magnitude 4.5s, 5s, 6s. So the number of felt earthquakes is an awful lot smaller.
These are what they call the aftershocks.
They're part of the sequence. An awful lot of them are aftershocks, but they actually had foreshocks as well. They had some earthquakes before the big ones, and that is, it's not unusual. It's been seen in other parts of the world, but it's not common. But yeah, a lot of these numbers sound impressive, but they're not the ones that you feel and cause the damage. It's the magnitude 6 that cause all the damage.
I understand aftershocks. How do you know what is a foreshock?
You only know it's a foreshock after you've had the main shock, okay? Because earthquakes come and go all the time. You get small earthquakes all over the place, all over the time. And it's only when you sit down and you plot the activity, and this is a case with the Puerto Rico sequence, there was swarm activity we use for the volcano, but there was swarm of small earthquakes during December, basically building up to the large one. And then you say, right, those were foreshocks.
Now, folks may not understand that under the sea, there are what we call these fault lines. And we have spoken, and maybe you can talk about the Puerto Rico Trench and other things. What would have caused these deep trenches? Because as I understand it, if you put Mount Everest into the Puerto Rico Trench, you'll just have a little bit sticking out. And Everest is 29,000 feet.
Yes, it's very deep.
That's deep.
So we talked about the subduction zone for the Eastern Caribbean. That's when 2 plates bump into each other and they're trying to push each other. When you go around the corner into the Northern Caribbean, you there have 2 tectonic plates that are sliding past each other, okay? So they're not pushing together, they're sliding past each other. And that creates this, what we call a transform fault. And that's a zone of weakness. And so over time, you can get erosion and other things, which basically forms a trench along that transform fault. But the trench is just the surface expression. There's a fault that goes down underneath, and the 2 sides are rubbing against each other, and that's where you get the big earthquakes.
The big ones.
Yes.
Which is better, a shallow one or a deep one?
A shallow one causes a lot more damage than a deep one. If you have a magnitude 6 at a depth of 10 kilometers, you're not very happy. If you have a magnitude 6 at a depth of 300 kilometers, you'll feel it, but you won't be getting much damage from it. So the shallow ones are the ones that are likely to cause the most damage.
So tell me, how can we here on Montserrat and across the Caribbean prepare for these earthquakes that, as you say, are inevitable?
Indeed. They are inevitable. They are a major cause of loss of life and loss of property in the Caribbean. We have to remember that in 2010, a magnitude, I can't remember the Haiti earthquake, it was 6 or something, killed 1/3 people. 1/3 people. It's an unbelievable number. So we do need to be prepared for them. And there's really 3 things we need to do, 3 things we need to be aware of. First is having your infrastructure built in the best possible way. There are building codes and regulations to build structures that, you're not going to build things that are resistant to a magnitude 8, but you can build things that are going to be resistant to magnitude 5s and 6s. So make sure everything is built to the proper building codes. We're quite lucky here in Montserrat. We don't have skyscrapers. Skyscrapers don't like earthquakes, and they're difficult to build. If you're building 1, 2, 3-story buildings, it's not so expensive to make sure you work to the building code. So infrastructure has to be built to the building codes. Then the second part is you need to know what to do during an earthquake, and that's the DCH, drop, cover, hold on. You need to know how to react, because you're not getting any warning. It will happen and you have to do something instantly. So DCH, get down, get underneath something and hold on to it.
But you know that is easier said than done.
It's easier.
People run.
Yes.
And they run outside.
Yes. But the advice is don't run, because a lot of people get injured by falling masonry. You try and run outside and something falls out of the building and hits you. And to be honest, you don't have the time. Magnitude 6 or 7 earthquake will be over in less than a minute, possibly. So all you have the time to do is to basically cover and stop yourself being... I mean, if the building falls on you, that's going to be very tricky. But you're really looking at minimizing damage for things like light fitments, or we've got 2 big loudspeakers in this room. We've got lights. We've got a big aircon. Those could fall and they could hurt either of us without the room being damaged. Getting underneath this desk that's in front of us will protect us from those.
But we are going to be trapped.
We can get dug out afterwards. We can get other people to rescue us. People have spent a lot of time and money studying this. And the best way to not to ensure survival, but to maximize your chances of survival is DCH. Drop, cover, hold on. Get underneath something and hold on to it.
But has this been tested?
Yes, it has. People have done lots and lots of statistics on this. Countries like Japan, United States, who have got the money to do this research, have looked at all of these things. They've tested different hypotheses, and this is what they recommend. If you're in a room that doesn't have a table to get underneath, you go to a corner, and you just make yourself as small as possible in the corner of the room, because the walls of the room are going to protect you. Running outside, you're going to open yourself to other problems.
I know you don't like to hear this, Rod, and some of your colleagues, not only at the Seismic Research Center and here at the MVO, but probably around the world, when they say that the Caribbean is overdue for this big one, I'm getting concerned.
I hate that phrase. It's because the earthquakes occur randomly. So sometimes you have big gaps between them, sometimes you have small gaps. So it's a long time since we had a magnitude 7 in the Eastern Caribbean. But it doesn't mean that the probability of having a 7 is higher now than it was 100 years ago. It's still the same probability. We are due big earthquakes, but I would never say we're overdue, because that gives a false impression of the sort of the science and the mechanisms going on. But we have to be prepared for these big earthquakes. So if telling people one is overdue helps us getting prepared, then maybe we should go with it.
But in terms of being prepared...
That's my third bit. So the first bit is infrastructure, build it properly. Second bit is know to do the DCH. Third is preparation. You should have an earthquake preparedness kit. And I've actually spent a large part of the last year putting one together for myself. It's not actually as easy as it sounds, just finding things, but having things that will help you survive after an earthquake. And basically, if you're in a big earthquake that destroys a lot of buildings, destroys a lot of infrastructure, no one's going to come and rescue you. No one's coming to help you. There's nowhere to go because all the other buildings are damaged. So you need to have a kit that basically contains enough things so you can look after yourself for a few days, 3 days, say. So that's food, water, some sort of shelter in case your building is damaged, tarpaulins for that shelter, food and water, clothing, other bits and pieces. There's websites that give you good lists of the sort of things you should have, and you should have this, and it should be somewhere outside your house, because you don't want to have to go back into the house to get it again.
But if we're under this desk,
yeah,
that's it.
We're under this desk, no, and then you crawl out. You get out of your building, okay? You've been lucky that it's not been a magnitude 8 and you're not dead. You get out of the building, you do not want to go back into that building. So you don't want to have to say, I need to go back for my shoes, because earthquake, you sleep 8 hours a day, that's 33% of the time. There's a good chance the earthquake will happen when you're in your bed. You don't have time to find your shoes. So you need these supplies to be outside the house so that you can use them. The sort of earthquake kit is very similar to what people talk about for a hurricane preparedness kit, things for your family, medication, various other stuff. But the hurricane preparedness kit, you have time to put together as the hurricane approaches. Earthquake, you don't have any time. So you have to have these things, especially the water, because the earthquake will damage the water mains, it will damage the power infrastructure. You need flashlights, you need batteries, you need all these things. Cell phones, and no one's really looked how well they survive. But yeah, you should have a cell phone. You should also have a radio, a battery-powered radio, so you can listen to what's going on. So we can listen to you telling us, giving bits of instruction. I mean, you think nothing happened, but you have to think what happened to those people in Haiti when they had that earthquake. They were in such a bad state that, they had diseases running through parts of the country because of bad sanitation, bad water, because they didn't have this sort of preparedness. They had very bad infrastructure. Their buildings caused a lot of the deaths. But you need to have some sort of kit, an earthquake preparedness kit, so that you can survive if you're in an earthquake that doesn't kill you, but it causes a lot of damage.
Which is a lot different from a first aid kit.
It's an awful lot. You need a first aid kit in there as well, okay? But yeah, so I mean, the kit is quite a big thing, and it's a bit of sort of time and effort to put together, but it's worth doing. It really is.
As you were talking about infrastructure, the Puerto Rico earthquake the other day was bigger, I think, than the one that happened in Haiti.
I think it was, yes. And that's a good example of construction, okay? Haiti is what's the capital of Haiti? Port-au-Prince. Yeah. It's a very ramshackle place. It's got lots of sort of shanty towns or these places, very thrown together structures. It also has quite a few sort of, not high-rise, but 5-story buildings sort of thing. I don't know how well they followed building codes, but it looks as if...
But you visited Haiti.
I've been Haiti, and you can't really tell there was earthquake damage because everything's a mess anyway. Puerto Rico, being in some way, well, it is part of the United States, they better have good, strong building codes. They really should. So I think their buildings are much more resilient when we have earthquakes. But some of the photos we've seen from Puerto Rico, you can see there was one example where there'd been like a car park under a building with these pillars, and all the pillars had gone and all the cars were crushed. The building basically fell one floor. So you're always going to get things. When you get into these really big earthquakes, magnitude 7 or 8, the shaking of the ground can exceed the force of gravity. So that means things just go into free fall, and you could never build anything to withstand that. So normal building codes, I think, are built to design shaking up to about a quarter of the force of gravity. But if you get things that are accelerating as fast as the force of gravity, then it's going to collapse anyway.
As I told you, Rod, I did some research, building on rock and building on sandy looms of sand. I understand that when you have an earthquake in a certain area, the ground just becomes liquid.
Yes. Yeah.
Why?
Because it's being shaken so much and it's got no cohesive sort of matrix holding it together. And this is the thing, there's a body of science that they actually look at the magnification of different building materials. And if you build on solid rock, you get a certain shaking. If you build on soft sand, the shaking might actually be twice as big as it is on the solid rock. So if you're building things on sand or reclaimed land, you have to put in better structures. You have deeper piles in to try and get rock and things like this. And if we get to these high shaking levels, when you've got unconsolidated sand, it will basically turn to a liquid and flow. And I've seen photos of buildings in Japan that just fell over because the ground disappeared from underneath them. That's not a problem we're really going to have to face here. We have small buildings where, the rock isn't very good here. It's all volcanic rocks. Liquefaction it's what we call this, isn't a huge problem. It's not our prime problem. But It's why you have to follow building codes to make sure that you make your buildings as resilient as possible to earthquakes.
I'm hoping that we're not scaring people, but this is a fact.
Yeah, we don't want to scare people. I would be so happy to go through my time in Montserrat, having put together my earthquake preparedness kit, never having used it. Okay? But we need to be prepared for things, and this is one of the things that can affect us here. Hurricanes, I think we're better prepared for because we've got experience of them. It's a more tangible threat. You can see it coming. People put things together. But we need to do similar things for earthquakes. So,
okay, earthquakes, but earthquakes happen at sea.
Yes.
And at depth.
Yes.
What about tsunamis?
That's another thing that we should be prepared for. Tsunamis in the Caribbean have not caused the huge loss of life that hurricanes and earthquakes have, but there have been very tragic tsunamis in the Caribbean, and it's something we have to be prepared for. That requires a different approach. Basically, your dangerous areas are low-lying parts of the island. We're very lucky. We are an island with quite steep slopes and mountains, and you don't have to go far away from the shore to be safe from a tsunami. I went to St. Kitts recently. The entire capital city is low-lying and is in danger from a tsunami.
Bastia.
Yes, Bastia. Luckily we don't have that. So to be prepared for tsunamis, again, it's an education thing. If you feel an earthquake that's so strong that it knocks you off your feet, or you hear a roaring coming from the sea, or you see the sea going out further than it normally should, that's a real sign that a tsunami might come. You head as quickly as you can for high ground. And DMCA, I know, have been putting up sort of signage for this sort of thing, marking areas in the low-lying areas so that people will know what to do when a tsunami comes. So different islands have got different levels of preparedness, but we do have signage here, and I hope that sort of tourists and visitors are very aware of what they need to do if there's a chance of a tsunami.
What about some of the other, and I'm just mentioning capitals in the Caribbean, St. John's, Antigua, and maybe some of the other islands that could be affected by tsunami?
They could be. I mean,
St. John's?
yeah, I'm sure it could. All the ports, because you're next to the sea, you can be affected. It really depends where the tsunami, the thing that triggered the tsunami, probably an earthquake, where that was, how well sheltered you are, stuff like that. People that work on tsunami preparations do modelling of all of that to work out the dangerous areas. So for St. Kitts, they've got a very, very good map which shows everywhere on the island that could be affected by a tsunami.
Frigate Bay?
I don't know St. Kitts well enough, but I've got the map at home. I'll show it to you one day. It's really nice. They've done the same here in Montserrat. It's quite simple to do. It should have been done for every single island. I just don't know off the top of my head because although I work for SRC, a regional organisation, my focus is Montserrat, and I can't remember details of all the other islands.
Well, Casby and Little Bay would be in problems.
Yes, they would be. So there needs to be signage in places like that. But it's easy on Montserrat to get to higher ground. You don't have to go very far. If you're on a shallow coral island, you have to travel a lot further to get to the higher ground. So we're good here as long as we have the signage and people react properly.
But if you had a big earthquake, let's say in the Puerto Rico Trench.
Yeah.
Puerto
Rico Trench.
Average time for getting to a place like Montserrat?
From the Puerto Rico Trench, 30 minutes.
30 minutes?
Yeah.
That should be enough time.
Yeah.
If you know what's happening.
If you know what's happening. But that's the thing. People have to make the decisions of what's going on. So the seismologists have to locate the earthquake first and decide if it is potentially tsunami warning. So that might take you 10 minutes. Then there are tide gauges around the Caribbean that should pick up whether there is a tsunami or not. That might take another 5 minutes. So your warning might only be 15 minutes. It might only be 5 minutes. It depends exactly where the earthquake is. So, we have the sirens, and DMCA should have them set up so we can use them to say if the tsunami is coming. But the best way to prepare is to look for signs personally. If you have an earthquake that is so big that you can't fall over, you can't stand up, you fall over, that means it's probably a magnitude 7 or so. Don't worry about whether it's at sea or at land or whatever. Assume it's got to do a tsunami and run. If you hear like the roaring from a jet engine somewhere out at sea, that can probably only be a tsunami. And similarly, if the water recedes further than it should do, that's a good sign. So in any of those cases, run for higher ground. Don't wait for any warning.
Again, that is easier said than done.
It is.
Because people like to look and see what's going on.
Yes, but we have to just keep reminding people, things like this radio program, talking to the kids in school, make sure people know what to do. One of my anecdotes from Trinidad, there was an earthquake there. It wasn't huge, but everyone felt it. And there was a school where all the kids automatically got under their desks. And the teacher was shouting at them, "Get outside, run outside, run outside." The kids knew more than the teacher about what to do. So we have to keep making sure that people know what to do. Radio broadcasts, working in the schools, having signs in places. You go to hotels around the world, on the back of every hotel room door, there's like a fire evacuation plan. There should also be an earthquake plan and a tsunami plan in the hotels so that visitors can read these things when they're there.
But won't people be scared if they see all these things, or would they feel safer?
No, because we give the message that although these things can happen, it's still a low probability. It's still a safe place to come. You just need to be prepared for them. I mean, when I was young, and this is a long time ago, I went to San Francisco for a scientific conference, and I could not believe that all these people lived there. Because at some stage, San Francisco is going to have a magnitude 8 earthquake. And the last one it had destroyed so much of the city. And it's like, why are you living here? But there are other reasons to live there. It's a good place to be. You just have to be prepared so you increase your chances of surviving if the event happens.
What do you think we should be doing right now in terms of education?
We should
not only the DMCA, but
we should be doing what we're doing. I mean, we have quite an active program with SRC, DMCA, other government agencies working in the schools, just keeping on with doing that, keeping things up to date, making sure all government people, especially the building of infrastructure, they're all aware of the need to follow building codes. And I think you've made a good point, making sure that visitors know what to do. Because similarly with the volcano, people that have lived here for 20 years know what the volcano can do. If you come here, you've never seen it erupting, you think it's just a mountain with steam coming out the top. So making sure that visitors know what to do. And if things do happen, making sure we have access to information quickly. With the volcano, everyone in Montserrat knows if the sirens go, tune to ZJB. That's how we put out information. They, I hope, would do the same if there's a big earthquake, because that's how we will put out information. So just keep educating people, and yeah.
At one time, Rod, I think there was a plan, I don't know if it was successful or if it was done, to set up these buoys throughout I don't know if it's the Caribbean Sea or near the islands, to detect whenever there's a...
tide gauges.
How far did they get with that project?
There are tide gauges on some of the islands, because those are cheaper to put up. And I know DMCA were looking at putting up some here. But the problem is the tide gauges out in the deep ocean. They're expensive to install and to maintain. And therefore, they only tend to be installed by the Americans for their tsunami warning system. So we have tide gauges on the islands. I think there's only one in the middle of the Caribbean Sea. So there need to be more of those. But the whole tsunami warning system for the Caribbean is something that a large number of parties are working on, are very active in, and is something that we need to keep continuing to improve. Last year they did an exercise of some sort, which I think was very successful. We need to continue doing that sort of thing.
Now, I found out during my research that with these tidal waves, you may be out in the ocean in a ship, and you don't know.
Yeah, you don't notice it going by.
Because the water is so deep. But
yes.
when it gets to the shore, that's when you get the big wave.
As the wave comes into the shallow area, then yes, it becomes an awful lot bigger, and that's where it causes the damage.
So that's the deception.
It's a deception if you're outside. That's why you need, if you've got accurate tide gauges, you can measure these things, and it is quite big. It's maybe a metre at sea, but when you're in the deep water, a metre's not a lot. But when it comes into land, it might be 5 meters, 10 meters. It gets huge. But you can measure the 1 meter tsunami at sea, even although it doesn't look very impressive to people that are there. I actually know someone that was in the Indian Ocean diving when they had the big tsunami there. They had no idea what was happening. They were underwater, offshore.
And they survived?
Yeah. They didn't know it happened because it was only a small wave when it was at sea.
Wow. Rod, this is going to be a breather. It's a question for a breather. How long have you been a seismologist?
Ever since I was a young lad. Since my 20s.
Wow. And how long have you been in the Caribbean?
12 years.
12 years.
I've been a seismologist at different scales. So at the moment, I'm really a volcano seismologist, but I've been an earthquake seismologist before that. I've been a seismologist at geothermal plants and things like that. I've worked around the world. But yeah, I've been a seismologist now for more than 40 years.
I'm going to ask you a question. I know that you will smile and give me an answer on the lighter side. The other day you got an award from one of those UK universities. And what was it all about?
I was made an honorary fellow of Edinburgh University. Edinburgh University is where I did my first degree. I studied geophysics there. And an honorary fellowship is basically just an award that they give to people that, the recognition that they've done something good either for Edinburgh or for science or something. I actually don't know how many honorary fellows there are. There might be hundreds of them. I really don't know. It's just a nice recognition from your sort of original university. It doesn't involve you don't get any payment or anything like this. If I lived in Edinburgh, I would be allowed to use the library, go into the department, have a cup of coffee, that sort of thing. It's like a staff member, but one that's not paid and doesn't have to do any teaching.
I'm happy to hear that because I was thinking for one moment, maybe they're giving him this because they're ready to retire him.
No, not yet. It's just a nice recognition from where I started my career, and it just makes you feel good that people sort of think, yes, he's gone out from Edinburgh and he's done some good things, and it's something that means a lot to me. So I was very, very happy to have been given that.
Okay, in terms coming back to the hardcore topics, SRC,
yeah,
Seismic Research Center,
yeah.
How busy, how serious would they be at this time?
They're always busy because they cover the whole of the English-speaking Eastern Caribbean. So they've got not one volcano, but is it 16? They've got earthquakes in different regions. There's almost always something going on. So at the moment, they don't really work on the Puerto Rico stuff because there's a United States agency that works on that. But they'll be working hard on the Dominica earthquakes. They'll be working very hard on the public information. I've seen lots of WhatsApp messages going back and forward about the information that's going out to people in Dominica. So yes, they'll be very busy, but they're always very busy.
But it's very important, the work they're doing.
Oh yes, it's very, very important. And it's very good that they exist and that they can do this.
But again, coming back to these trenches across the Caribbean and all these fault lines, has anybody put their finger on what causes all these?
It's plate tectonics. It's this thing about having the crust of the earth is mobile and these large plates.
So people think that the earth is solid and it's just there, but it's always moving.
The crust is always moving. It's just moving very slowly. So we have these number of tectonic plates and 6 or 7 large ones and quite a few smaller ones. And they're moving around, but the speed they're moving is centimeters per year, which is about the same speed that your fingernails grow. So they're moving very slowly. But they're...
Why did you say that?
Because someone taught me that a long time ago. And it's because you know how fast your fingernails grow. You don't see it when you're looking at them, but every now and then you have to cut your fingernails so that they are growing. So they're moving slowly around and they're pushing into each other. And that's what's the cause of all these earthquakes and the volcanoes throughout the world.
Yes, something else I wanted to add in here, Rod. We're talking about the Caribbean.
Yeah.
Folks may think it's just a few islands, but it goes all the way down to the Americas. Because Honduras and those places, it's all part of the whole system.
the whole world is part of the system. But we have this subduction zone, which goes all the way from basically Ceiba in the north down to Grenada in the south. So we have earthquakes and volcanoes throughout the length of that. Then we have the two northern and southern boundaries of the Caribbean plate, which are transform faults. So one's off the coast of, it's basically the coast of South America. The other's the Puerto Rico fault. And then Central America is really the other side of the plate. It's a bit complicated what happens there, but it's an area, again, where you have volcanoes and earthquakes.
And then we have what we know as the Ring of Fire. That starts somewhere, I think, down in Peru or somewhere, then goes...
It goes all the way around the Pacific. Okay? But that, in some places, that's a subduction zone. So off South America, that's a subduction zone, the same as we have in the Eastern Caribbean. But when you get up to California, it's a transform fault there. Then it goes around Canada, Alaska, and then you're back into it being a subduction zone all the way down to Japan. So these are similar mechanisms in different parts of the world.
Okay, Rod, I'm going to take another short break here, and we're going to play another one of our promos that has to do with earthquakes. And I'm just hoping that folks will listen and understand.
What should you do when an earthquake strikes?
What you gonna try and get out the house?
I'd run.
Get outside the building ASAP.
All wrong answers, and what you don't know can kill you.
Do you know that more people die from running in an earthquake than from staying put?
Surprised? Sure, but what do you do? Just sit there in the middle of an earthquake?
Just remember 3 things that could save your life in an earthquake. Drop, cover, hold.
Drop. When you feel an earthquake, drop to the floor. It's actually the safest place in the building.
Cover. Get under a bed or sturdy table and cover your head. It's protection from falling debris.
Hold. Anchor yourself to a firm support.
Stay right where you are till help comes, or until it's safe to come out. Because what you don't know about earthquakes
can kill you.
Okay, so we are back, Rod. Again, coming back to the regional earthquakes. Where do we go from here?
We just remember the DCH. Remember the DCH to do during the earthquake. Put together your earthquake preparedness kit and enjoy life.
I asked you a few weeks ago, you have a shovel and a pick, but they would be short versions of what we normally have. You can't use a big pickaxe if you're buried.
No.
I was looking at something with a short handle.
No, but again, if you get buried, you've got to get out. Your kit isn't there to help you get out. Either the most likely scenario is you can get out of your building, you can walk out. It will just be partially damaged. And then the reason you have a shovel is because you're going to have to dig a latrine if you need to use the toilet. The pick is not so sure. So yeah, you can use shovels. I mean, I've actually got a folding shovel, because it's a thing that volcanologists seem to have. But you have them outside. But it's not to get out of the... if the buildings collapse on top of you...
You cannot get out.
That's when you have to wait to be rescued. But we're really talking about the situation where the building has got partial damage, you can get out, and then you need to do things basically in your garden or around the house, because you don't want to go back into the house. Because one of the big problems is aftershocks. Big earthquakes always have lots of aftershocks. These are usually smaller than the big earthquake, but buildings will have been damaged already by the big earthquake. So an aftershock may cause further damage, may bring the building down. So this is it. You really need to be able to survive in your garden until the rescuers can come to get you. So that's where you need the shovel. You need toilet paper with the shovel, other things so that you can live in your garden.
And a lot of water.
You need enough water, yes.
How about if you're traveling in your car and the earthquake hits? What do you do?
If you're traveling in your car, you're not inside a building, so you don't have to drop, cover, and hold. The important thing in a car is don't park underneath a bridge. And we don't have many bridges on Montserrat to park underneath, okay? Don't park under a bridge, just ride it out. Just stop, because trees may come across the road and things like this.
But suppose I'm on Fog at the Hill, or where we have one of these high cliffs, what do I do?
Stop, because you really don't have time to go anywhere else. I mean, if you're in the car, you can get out your car. You can. If you feel that you're on a cliff edge and you don't want to be there, yes, get out of your car and move to somewhere that is not so exposed.
Folks, if you're wondering who I'm speaking to Rod Stewart. He's the resident seismologist at the Montserrat Volcano Observatory. And of course, you would understand we're talking about earthquakes and tsunamis because of the number of earthquakes we've been having across the region, especially for the past few years. And we're just getting some education here from Rod as to how to prepare first of all, and what to do just in case that we have one of these bigger earthquakes and we have collapses and everything. But it has been a bit breathtaking. I have spoken to Rod maybe hundreds, thousands of times as a volcano seismologist. But with dealing with these regional earthquakes, it's a little different, Rod. It's a little different. And in terms of, I'm going back to Willie Aspinall and the things he taught me about listening and sound and the P waves and the S waves. Explain that to us again.
Oh gosh, we're getting very technical now.
Well, sometimes we have to. but there are sounds that come from an earthquake.
Yes. They're just at different frequencies. They're outside of our hearing frequency. So a P wave is very similar to just a sound wave that you hear in the atmosphere. It just travels through rock instead. But the frequencies are much lower, so you're not going to hear them.
And the S wave?
The S wave is another type of wave which doesn't exist in the air. It only travels through rock. It's just a different sort of mode of the rock moving, of transmitting energy. But these are things that we use scientifically to study the earthquakes.
Well, I don't know what Willie did. I'm not sure whether he slowed it down or sped it up.
He speeded it up.
But I heard this boom, boom.
Yeah. It's a very common thing for people to do when you've got a sequence of earthquakes. It's just to speed it up, and you move the frequencies into the audio range, and then you can hear.
And humans can hear.
And humans can hear what it's like. But it's a toy, basically. It's something you do to impress people.
Well, I was fascinated by hearing the P wave and the S
but
wave.
As a seismologist, there are actually 4 different types of waves.
4?
4, sometimes 5. And you can try and distinguish between them. You can use them scientifically.
Oh.
So there's a P wave, there's an S wave, there's a Rayleigh wave, there's a love wave, and there's a T wave. So
a love wave?
A love wave.
What's that?
It's just it's named after someone called Love. Okay, it's got nothing else to do with it. But there's just different modes of waves traveling in the earth.
Okay, so Rod, in wrapping up, we've had these earthquakes right across the Caribbean. I think Puerto Rico, the ones in Puerto Rico, they have been the most intense. And you say we just have to move forward.
We have to be aware of what might happen, make sure we know what to do, and be prepared. Yeah.
Just be prepared.
Be prepared.
And try and get yourself an earthquake kit.
Yes.
Well, thanks for talking to us, Rod. And I'm sure that you have enlightened the darkness of many of us.
I hope so.
I've spoken to you many times, and some of it I probably know. But just to hear it again convinces me a little more that I must have my earthquake survival kit.
Yes.
So once again, Rod, thanks for talking to us. And we're going to end, of course, with this DCH. And let's just hope that we have been of some use talking to folks, not only here in Montserrat, but across the region in terms of the activities beneath us and beneath our ocean. So once again, thank you very much, Rod Stewart. We were talking to Rod Stewart, our resident seismologist at the Montserrat Volcano Observatory. Thank you once again, Rod.
Thank you.
And for ZJB Radio and the Montserrat Volcano Observatory, I'm Winston Kafu Cabey. Thank you for listening.
What should you do when an earthquake strikes?
What you gonna try and get out the house?
I'd run.
Get outside the building ASAP.
All wrong answers. And what you don't know can kill you.
Do you know that more people die from running in an earthquake than from staying put?
Surprised? Sure, but what do you do? Just sit there in the middle of an earthquake?
Just remember 3 things that could save your life in an earthquake. Drop, cover, hold.
Drop. When you feel an earthquake, drop to the floor. It's actually the safest place in the building.
Cover. Get under a bed or sturdy table and cover your head. It's protection from falling debris.
Hold. Anchor yourself to a firm support.
Stay right where you are till help comes or until it's safe to come out. Because what you don't know about earthquakes
Can kill you.